Good evening, students. We'll start in 5 minutes. Hello, students. Let's make a slow start and take it from there. Let me know if my screen is visible and my voice is audible clearly with a thumbs up or a raised hand. Okay, so my voice is clear and screen is also visible. Okay, fine. Um, So today's agenda, tips on data science, Python and AI ML as usual, the starting point of it. Um, Statistical tests overview and regression using Python, right? So that's our agenda for today. Firstly, tips. How do you use mean, median, uh, and mode for treatment of missing values? Home loan example that we discussed yesterday, it's in the video, and it's independent variable analysis. Then I have given you one link which you can explore on your own from a blog. Then I told you how to follow, right? So there's one person called as Venkat Raman. You can follow him on LinkedIn for good posts on statistics. There's also this 100-page machine learning book by Andrew Burkov. There used to be a free version directly, which you can see also. You can also follow Andrew NG. There is also one more person we can follow. Let me just give you his name also, an update in the deck. Just give me 1 second so that we don't miss out on the names and I don't forget. So I find his posts to be very interesting. So this is the person. Okay. He's from Meta. Some of the free trainings of Andrew NG are very good. Or let me write see his free trainings, especially. Okay. Fine. So check these things out, right? There is this data analysis process in analytics, which I will run you through very quickly in some time. Venkatraman, as I mentioned, and this person is VP in Meta. He has some very interesting posts. Andrew Burkow, probably one of the few people who has written a few good quality book on the machine learning, the ML book. Um, so it's after reading also you can pay something of that sort, right? Okay. So does everybody remember the tips? Is my voice breaking for others also? Or can I get a thumbs up and raised hand if everybody can hear me clearly? Anshika is saying she's hearing breaking. My voice is breaking for her. Okay. For others, it's very clear. Okay. Okay. It's perfectly fine. Anshika, you probably need to check your connection. Okay. So check these things out. Uh, Let me update and other techniques for treatment of missing values. Home loan analysis, home loan example and its independent variables analysis. We discussed little bit of EDA, but that's a separate topic we will cover, right? So that's about that. Let's see our first topic, which is data analysis. So you can see that, right? So this is related to AI ML in the sense data analysis, process in analytics, and data science. How do you handle it, right? So what I've done is there is a Wikipedia article, very good one. I've taken and expanded it somehow. So expanded it. So what are your steps for data analysis? What should the general data analysis steps be? So obviously you have to set up your process, right? Whether it is in now, why do we first of all talk of a data analysis process? Because ultimately you will do something with AI/ML, right? You will analyze some sort of a data, build a model, process information, and so on. So before you do that, you need to understand these steps so that it makes sense to you, right? And we'll see that in a minute with other articles as well that I have stored for you, right? Just give me a minute. Let me share again. Right? So data analysis and the process is a very important thing to be aware of, correct? Now, obviously, your first step is to know your process. Your first step is inspecting of data. You do a visual analysis using view in R or object or whatever way you put it in a data frame and analyze it. If required, you clean it. We discussed about little bit about cleaning and processing missing data yesterday. Then you do the processing, including dimensionality and feature engineering. What is that? So let's go back to our in parallel our um, Excel sheet, and I will show you. Then do the transformation modeling and then communicating it, right? And obviously a functional feedback loop. So let me open yesterday's Excel and explain each of those steps to you, right? Right. So this was our yesterday's Excel, right? Our first step is to clean it. We inspect the data. How do you inspect it? So let's write our hints here. You can do EDA, exploratory data analysis, which means you do a box plot, you do a histogram if it's required, you do a scatter plot, you do a heat map, you do a pie chart, area plot, and so on, bar plot, and so on. You do all such things and try to visualize the content in a way so that it starts to give you trends, right? Now, what can be your trends? Like yesterday, we discussed some of these trends without me explicitly telling you what was happening. As we see, many people are taking loans in the age groups of 20s to 30s. People taking loans during 45, 50 and above are less. It's not as if they are not there, but they are less in this data set. Obviously, the data set needs to be few thousand at least, but we are only seeing 17, 18 entries, right? So these kind of outliers is something that a box plot will pick up for us, right? Similarly, if you do this analysis of salaries, you will see that probably 30 lakh, anything above 30, 35 lakh is an outlier. A typical family is earning, let's say, between 2 lakh to 2 lakh to 30, 40, 50 lakh when two people are earning, let's say, in a nuclear family or a small joint family, right? So in that sense, you pick up such outliers as well using box plot. You do heat maps to understand the correlation between variables. You want to see whether increase in salary moves with the increase in CIBIL score and the loan gets approved, and also the income of the person who is taking the loan is also good and the age is less. Because as your age goes up, the years of home loan that need to be paid off decrease, right? The years decrease for us, right? So these kind of things are something that we do as a first step where we inspect the data, right? We inspect the data. My screen is visible to all, right? Yes, it's visible. So that's our first step of inspecting our data in terms of understanding it. Then comes cleaning it. Why is cleaning important? Because it might happen that you realize that there is some mistake. Suppose you see an entry here. Suppose this is for middle class. Okay. So, how do I define middle class? So I'm not an economist, but my learning is if you talk of middle class, the family income for a year will be anywhere between 5 to, let's say, 60, 70 lakhs or something, including all people who are earning in the family, approximately, right? Or at the max 75 lakhs, right? If it's a big family of 7, 8, 10 people and 2, 3 people, 3 people are earning or something of that sort. What I was reading is, if I'm not wrong, more than 90 or 95 percentile of people earn up to 15 lakhs only in India, right? So, as such, if in a family you have 2, 3 people who are working, right? Let's say 3 people are working, it's a typical family, then you will earn 45 lakhs, right? It's not as if that everybody earns a 1 crore. Those are 1%, 1 to 5% of the population, right? Only 1 to 5% of the, and that's true across most economies, right? So 90 to 95% of the people of, based on what I read on Economic Times or somewhere, are earning up till 15-20 lakhs, right, per person at the max. So cleaning is also important. If this graph, if this table represents family income, if this table represents family income, then what we need to understand is any income for a family which is above, let's say, 75 lakhs to 1 crore at the max cannot come in middle class. That is not middle class as per me, right? So at that point of time, you need to clean the data. Why? Because if you have to give a loan, giving loan to high net worth individuals is very different. The chances of them not repaying are less, right? Because they already have so much income and their loan requirements will also be a lot higher, right? So cleaning data is our next step, which we need to understand. After that comes the question of dimensionality reduction and feature engineering. Now, what is that part? Let me explain. So let's add few more columns here. What all we can add, like I was adding yesterday, home loan amount, home loan duration, right? Phone number has come, email has come, gender is there, income, guarantor income, CIBIL score, home loan amount, home loan duration, property area, property size, right? Property size, and so on, right? So many such columns can be added. Now the thing is, we want to analyze two important things. One, if we write yes here for a high income person, let's say in this range, for a loan that is given based on, let's say, logistic regression or whatever, should we be mapping all these variables which are there? I don't think so, right? If these variables all move in the same direction with increasing value, then it may be worthwhile to only consider few of the variables there, like CIBIL score, guarantor income, and probably age. But age, increasing age means sometimes it's good, sometimes it's not good, right? The loan duration then gets affected. So that way we need to do analysis, and this analysis where you want to reduce the number of dimensions, which means the columns here, is called as dimensionality reduction. Because you don't want to feed the model with unnecessary data. Like typically think of it, if the guarantor income is very high, there is less chance of default or completely the loan not being paid off. If the CIBIL score is high, again the same thing. If the age is between, let's say, 30 and 37, 38, high chance the person will return because they might be settled in their career. If the number of dependents are less, let's add dependents here, right? If the number of dependents are less, again, and the guarantor income and CIBIL score is high, high chance that the loan will get repaid, right? So many such factors are there. All these factors, when you try to reduce the number of columns that will be fed into the model, that is called as dimensionality reduction in the simplest of terms. So that's your next step. Then comes feature engineering. To give you the simplest example of feature engineering, add the income and guarantor income together, right? And you get total income. I can create a column here, which is not there for other things, and write total income. Now I can add both of them. right? So I can add both of them. Now, what does this tell us? It tells us it's a new feature that we have created, and it tells us, what kind total income the person and the guarantor has. You can also do interesting things like your home loan amount and home loan duration. You can divide it and create a ratio. Let's do home loan amount by home loan duration, right? You can create that. Another feature that you are creating, property area. Suppose this is a from pin code, you convert it into three areas: costly area, mid zone, and let's say less costly area. And you define some parameter for it, right? Like this much square feet cost and so on. And those three, again, you can divide or compare or do something to create a new feature there. Again, there is property size also. So property area and property size. So many such things we can do which make sense to us, and that becomes our feature engineering. So our first step was data inspection. We created charts and graphs. Next step was our cleaning it. Obviously, there is treatment of data in terms of missing values. And from there, we move on to dimensionality reduction, feature engineering. Then you do the transformation and modeling. Transformation is another step. Like when the models work right on the data, the lowest value can become, let's say, 0 or 0.1, and the highest value can become 1. Like that is called as normalization at times in our data science world, right? Why do we again do it? See, income can be anywhere between, let's say, 2 3 lakhs and right up till 75 lakhs. It is a very large number in terms of what is possible and what is not possible, right? So before we feed into a model, what we do is we normalize the data between 0.1 and 1, so that we are able to manage it better in the model. CIBIL scores. Now see, here the value is this much, between 20 lakhs and 75 lakhs or 1 crore. And here the values are between, let's say, 400 and 900. So the lowest score, let's say, is 300. You take 300 and make it as 0.1, and 900 you make it as 1 highest score. It won't be that much, but maybe 850 or 890 and 890. So at that point of time, your model becomes, it has easy way to process, to tell that to you again. This is 75 lakh income. This is 2 lakh income. Let me consider this as 0.1. Let me consider this as 1. Okay. My CIBIL score, 300 is 0.1. 890 is 1. Now, what this does for me is it gives me um, a normalized number, and all values will be extrapolated or interpolated between these two values, and then that will be fed this one into our model, right? The regression model that we build, right? So that is one of the next steps that we follow. And lastly, obviously, communicating it, which is visualization. So build out charts, graphs, reports out of it to communicate it. So are these steps sort of clear? Again, this graph topic, okay. You can do data cleaning in Excel depending on how complex the data is, Namita, and what all work we want to do. Depends, right? And in the simplest of terms, yes, we can create columns by using available data as per our need. Yes, but columns, in the sense, we call them features, right? So I am super simplifying for you to explain, but those are actually features. Then comes the question of explain graph topic again. Okay, I will explain. So see, our first step was obviously inspecting the data. So that is where we build all these graphs using exploratory data analysis. To what do I mean by that? So you must have studied in statistics or other mathematical subject, Like if you build a box plot, you can see the outliers. What is an outlier? So as I was explaining, in middle class income, before I go on to process this data set, I will remove all people above, let's say, 75 lakh family income. This is a family income data set, as I have written here, right? In a family, if the total income, let's say up to 10 people who are there, is up till 75, 80 lakhs, then we consider them middle class. Okay. But if income is above 80, 90 lakh, 1 crore, and so on, then we cannot consider them as middle class, right? So that is something that you find out using box plot. How does it work? So let me, okay, so now that you are asking, exploratory data analysis is a separate topic we are going to cover, but let me show you box plot. It looks like this. This is the simplest analysis. So see here, your values for whatever variable, let's say income, it is between 2 lakh and 75, 80 lakhs. Then the values outside this box plot that we do are uh, um, uh, outliers, right? Are not of interest. Like CIBIL score. So our CIBIL score, again, if you plot, majority of the scores will be, let's say, between 400, 500, and up till 800. So those are of our typical interest areas, right? So box plotting we do, and based on that, we try to find out the outliers, which means the values which are not in the standard range for us and not of interest. There is actually a lot more to it, but I'm kind of simplifying for you and um, putting it across. Is that now clear? Yes, Namita, sort of. Right? So that's your um, uh, steps that are there, which we need to be aware of to start off our data analysis at high level. Now let's go back to our blog and let's see what else is there. Next step is obviously understanding what type of data it is, right? It could be quantitative or it could be qualitative, in the sense it could be natural language kind of a thing, or it can be time series data, it can be ranking, it can be part to whole, deviation, frequency distribution, right? And so on, right? What type of data it is. It can even be geographical or geospatial, right? In the sense that type of data which is there. Next step is you obviously check using formulas, relationships between them, and checking things like, is there correlation, is there necessity, is there causation. From there you go on to check about filtering, sorting, checking range and classes, summary, clusters. This is where the EDH starts, right? From there you check biases. Now, another important topic which comes up, right? So, very good. So, this is our data set, right? We are at a step of bias. Now, it can happen. Even I may be carrying biases, right? I might have my own set of biases. Bias means I might just decide that anybody above 1 crore cannot be a middle class person, a family. But I can be wrong also. Can you tell me how? Yes, Namita, you are right for your question, but can somebody guess when can a 1 crore income family be middle class also? So let me explain that example. Somebody who lives in New Delhi, let's say, or Mumbai, the work that they do requires them to live in the costly areas. So their flat or apartment cost will be, let's say, 5, 6 crores at least. Okay. And they have a family of 7, 8 people. So they need a 4 or 5 BHK or at least 6 BHK, right? At that point of time, their income may be above 1 crore, but their lifestyle will be very similar to us, right? Yes, but that's what I'm trying to explain. Not even expenses, more family members. Correct, Abhishek. So two reasons I can explain. One is living in a very costly area. If you go to costly areas, it is a compulsion to live there, right? Like suppose somebody is working in stock market or somebody is working for the government, let's say central government, and they have to live in New Delhi only so that they can support them, right? At that point of time, the person may probably have expenses which are very high, and also they have a large family. They have a joint family in Delhi or let's say South Mumbai, which is of 7, 8, 9 people. They need a 5 or 6 BHK. So at that point of time, probably their income will be, let's say 4 people are earning 25 lakhs, they are getting 1 crore, but their expenses will also be there because there are 8, 9 people in the family in South Mumbai or New Delhi, right? So there is something called as purchasing power parity. With 1 crore rupees in a tier 1 city top area, you will be able to buy less compared to the same income in a tier 2, tier 3 city or a village where you can buy a lot many more things, right? So that's one thing that you need to remember. Probably I'm carrying a bias that I said anyone above 1 crore cannot be middle class. So they can be middle class when something of the sort that I am telling you happens. When I am collecting data, see, I had a bias. I assumed that because government is giving duty benefit to females, most will register the property in the name of females, right? This is again a bias that people want financial benefit. So while collecting data, I am only focused on this thing. Do you see that? And I pick up those examples. I could also have a bias saying probably that this area people are rich. Not everybody could be rich, right? In that area. So people carry lot of biases inside them. We also need to be careful with debt and experience. Yes, Kamal says. So uh, um, it can also be that I uh, carry some biases which I don't realize, right? So there are multiple types of biases in all human beings. It's a separate subject, right? But the point that I'm trying to put across is as a statistician, although we are not statisticians, but we are like managerial statistics is what we are learning, right? In terms of managerial statistics and managerial economics, which is a subset of the overall subject, we need to understand that if our data set is filled with biases, we need to remove them, right? People carry a lot of biases. People carry biases related to what we eat, how we sit, how we talk. Somebody doesn't speak a lot of Hindi or let's say Tamil, okay, only speaks English. So we might carry a bias that the person is very well educated, but he or she may not be. So it depends, right? There are very many implicit biases that are built in our mind that affect how we collect data and process it. So we need to be aware of that. Is what we are trying to put across in this point. Let's go back to our topic. So that was bias. Then we actually check quality of data, measurements, transformation, observation into log scale as might be required for earthquakes and so on, right? So that's another thing we need to be careful of. Then obviously we checked for outliers and missing values, randomness, very important in all these things. Then we build the model of regression or whatever. So building the model and processing the data is actually step 8, right? Out of the 10-step process. And then you obviously go and do the testing and finally the feedback loop to improve the data, right? So that's your multiple steps to work on data science using AI/ML. You just don't directly take a data set and apply, okay, so it is categorical or it is continuous or discrete or something of that sort, part to whole. So I will apply this test or that test, or I will apply regression. We don't do like this, right? That's what I was trying to put across, that that's something we need to be aware of. Out of the 10 steps, the AI/ML model step is actually the 8th step. Okay. as you saw. Fine. Let's go to our presentation. Is that clear for everyone? Can I get a thumbs up if everybody has understood what I was trying to convey? Okay. So that was the data analysis process, very important to understand. And Wikipedia. And by the way, Wikipedia and few other sites are very good. Today I found one very good site for statistical tests, scribber.com. So let's start with the statistical tests. I'm not a statistician. As I said, I am a managerial economist and managerial statistician, right? So that is something like a subset of the actual guys. So we will see some good sites from where we can pick up such content and understand, right? So everybody can see my screen. Okay. Now, so this site is called a Scribber. I found the notes to be very interesting and good, right? If you look on the left side, lot of statistics related links are there, and we are just seeing the choosing the right statistical test, because that was our next topic in terms of hypothesis testing. So what is it? What we are trying to do here? We are trying to determine whether a predictor variable has a statistically significant relationship with an outcome variable, or estimate the difference between two or more groups, right? We are trying to do this. Now they start with a null hypothesis, which says that no relationship or no difference between the groups exist. And then from there, they determine whether the values predicted by the null hypothesis are okay or not, right? Now what they have done is very interesting. They have obviously discussed the statistical tests, what they can do, which we just talked about, and then they talk of the p value, which tells us how likely you are to see a difference, right? Higher the value or less extreme than the one calculated, then there is no difference. And if the value is extreme, then there is a statistically significant relationship between them, and so on, right? But what is interesting is they have given us a statistical tests flowchart, like you see here, and they have also described the various types of data types, because that I know is going to be the next question. So that is what type of variables they have discussed here. So continuous, discrete. Continuous is like 0.75 gram, one tree. Categorical variables, which we were discussing. So in terms of rankings or brands or win or lose, and so on, right? So all those kind of things they have explained here. Regression, they are explaining as cause and effect relationships. We are going to see some amount of regression today, right? So we'll try to see simple and multiple linear regression. I don't think we'll be able to cover logistic regression today, but they discuss what type of variables, predictor variable and outcome variable is there. Here it is binary, it is different. And the comparison tests, right? So very nice charts in terms of when do you do what type of test. Categorical outcome is quantitative, categorical, quantitative, and so on, two or more variable. And then chi-square test, R test, and so on. One by one, they are explaining in which situation what to apply. And they have built a flowchart also here, right? So again, my request to all of you is to not mug things up, because many people do that. It is better to understand. And how do we understand? As per me, what I would suggest is first try to understand the various types of data which are there on the link that I have given. These are the types of data which are there. What is the dependent and independent variable? Independent or outcome variable is what dependent and outcome variable is the one which is your uh, outcome, right? What you want to predict. And your in a predictor variable or the input variable are again the things that you feed, right, to get an output. And then you see this flow chart and the notes on regression and so on, and decide what type of tests or other things are to be done. So one side they have explained the categorical variables, what are the tests for it. The other side are the quantitative variables. For parametric tests, there are two ways to do the tests, right? And then they draw it down to t-test or ANOVA, MANOVA, simple regression, multiple regression. We'll see this today, right? Then if it is categorical, then we do logistic regression, right? And so on. So that is how they have given this link. Out of the links that I researched, somehow I found this to be very good because it has tabulated everything and also given you a flowchart kind of a thing. So visually pictorial kind of a thing is always helpful. So I have already put it into the links that we have. You also do one thing, that in the sense bookmark it somewhere for your reading. I also want to show you all the other things that they have added, right? So if you look on the left side, data collection guide, experimental design, type of variables, right? Types of data, descriptive statistics, probability distributions, which includes your yesterday's discussion of normal distribution, very small discussion we did, right? Inferential statistics, from their central limit theorem, hypothesis testing, which we are just now discussing, p-values, statistical significance, errors, correlation, and so on. So very good links in terms of notes that are given. So I would suggest storing this for your use. On date of data types in Python. So don't confuse data types in Python with Devi with the data types here in statistics, because they are different. That is meant for programming, and we will model the data types that we have here into something in Python, right? They are not exactly equal. So that's one thing we need to be aware of, Devi. But I will definitely give you the data types in Python by tomorrow in the hints section. Is that okay? Yes, this is already in LMS. Yes, definitely add it to your notes, Devi. Right idea. I have already added it. If you look in the presentation, this Scribber link, which I found to be good, I have already added it in the presentation today from Scribber, as you see. Do you see it? Is everybody able to see this? If you click this link, it will take you to the note that where I have put in the LMS, right? So let's go back to that. So I have learned one thing, which is, and no offense to anybody, I also used to find mathematics difficult earlier. So what I always do is learn it pictorially using visualizations and tables and so on. So some of the places where I've found uh, very good trainings are where there is visual, pictorial, flowchart, and such things available. So that is what I tend to refer to you all as well, right? So you should learn little bit of calculus in terms of differentiation, integration, which is opposite of it. What are its uses, area or the slope, partial derivation, differentiation, sorry, and the rules of calculus and so on. So all those things and little bit of statistics, at least at the managerial statistics level, to understand all these topics at a high level, then that will be very helpful in data science for you, right? So I tend to use such sites, and I would suggest that you also do the same. Okay. Now let's go back to our next topic, which is regression. So let me see. Perfect. So it has opened. Let's work on regression today using Python. I've already added this link. Let's try it out. My screen is visible to everyone, right? Okay. So what we will do is we'll understand it by example in the simplest way, right? I'm going to also tell you the theory, but let's first see the example. Let's create a new file. Let's give it a name. So what we do is there is one function which calculates the coefficients in terms of uh, mean and the slope and so on, right? And then we have the actual values, right? This is our these are our values. And from there, we plot the regression line using one simple equation y is equal to mx plus c, right? And we feed all the values in it, x, y, and b. B we are calculating from, I'll show you, right? So we are calculating it from here, this one, right? So to explain, let's make it markdown, right? We have a data set. The data set is what x is equal to whatever the values, any integer values like what we are seeing above, 0, 1, 2, 3, 4, 5, 6, and so on. Y is another set of values, right? 1, 1, 3, 2, 5, 7, and so on. Now, what we want to do when we plot it, it looks like this. It looks like this. See 0, 2, 4, 6, 8, 2, 4, 6, 8, X and Y. We are plotting it on kind of like a scatter plot, and we see all these points on this scatter plot. Now, this doesn't, it does tell us a trend, but we don't understand the full trend. So what do? We want to draw a line between this. And if you remember, the equation of the line is y is equal to mx plus C, right? If you remember, and that's what they are explaining here, but they are using very complicated language, which is h of xi is equal to beta 0 plus beta 1 plus x1 xi, which is basically y is equal to mx plus c. Okay, that is what it is. So we try to plot it, and for that we need few things. We need what slope the line will have and what will be its things. So if you look here, that is what we are doing. We first estimate the coefficients and then we plot the regression line for each of them, right? How do we calculate the coefficients? We have formulas for it and we directly use those formulas and calculate it, right? So we do the mean, and after that we do the cross derivation and so on, and then we get the regression coefficients and we plot them. Check them out in your free time. And from there we plot, and once we plot, it gives you a trend line which will look like this. See, if you see now, at any place, if you give a x value, you will be able to get an approximate y value. Now remember, this is some sort of an approximation. Right now, thing that you need to understand is neither we are overfitting, neither we are underfitting. But there will be differences between actual value and what we are trying to predict. So this is kind of like an approximation that we build to show the trends, right? That's what we are trying to do. So if you look at this, actual X value here is somewhat around 7, and here also 7. But what we are getting is around 6, 4 and 6. It's actually 4 and 7. We are getting 6 and 4. So slight difference. But we are trying to plot an approximation. This X and Y can be anything which is moving together. In this case, uh, could be, as I have always been giving that example, water requirement in an area with the temperature, right? So if the temperature is in the low 20s, or if it is in the low 40s, what happens, right? And so on. So the water requirement obviously for the city will go up. In winter, the water requirement will be less for any city, right? So you could plot such lines there and try to understand using simple linear regression, right? The equation is y is equal to mx plus c. M is the slope. So you do one thing, y1 is equal to m1 x1 plus c1, or c, whatever you want to write. Y2 is equal to m2 x2 plus c, and so on, right? You can create your equation and solve it and get the slope values, and from there you plot the line and you get the answer, right? So that's your simplest form of simple linear regression which is there, right? um, Yes, so very good point, Namita, you make, which is the error. That is what I was discussing. That is why it is an approximation. So good point. Y is equal to B0 plus B1 x1 plus B2 x2 plus error. Yes. And we want to orient the line in such a way that the error is the minimum, right? Where the error is minimum, right? Whether we want to push the line slightly higher from this area by changing the slope, or here and so on, right? So those are some things that we need to be aware of, right? We want the error to be minimum, right? That is what is the, like we have performance tuning in computer science, you have parameter tuning here, right? And so on. Okay. Okay. So again, please explain the plot. So what we have done is, see, when we start, Devi, this was our plot, right? This was our plot. Okay. We have X value and we have Y value. Think of it in the simplest term. We have X is water requirement of a city and Y is the temperature. As the temperature rises, the water requirement also rises. If you look at X and Y value, you will see here things are like this, right? At any point. Now, in regression, what we are trying to do is we are trying to draw a line here so that it tells us the trend, an approximate trend between the points, right? That is what we are trying to do. The lines plot equation is y is equal to mx plus c, right? Obviously. So that is what we are trying to plot. M is the slope, right? So we calculate it using the coefficient xy function, put it into this, right, by passing b, if you see the slope as required, and then we plot the line here to get this answer, right? That is what we are doing now. See, there can be a point here also. We actually got 1 2 3 4 5 6 7 8 9 values, but what if I want an answer at 7.5, which is here? So I will get an approximate answer which is, let's say, 9.5, right? I don't have to go to the closest one. I have approximate answers for all the points, right? On my x-axis or y-axis. That is what we are trying to do here. Got it? Okay. So that's your first topic. Now I'll give you 5 minutes to, just 5 minutes we'll take for a break, and then we'll see multiple linear regression. Okay. Very similar, but with multiple uh, predictor variables, right? Outcome is obviously one only, but we'll discuss some interesting concepts there and heat map also. Okay. Let's connect back in 5 minutes at around 8. Between 8 and 8:05, we'll start. So, students, let's make the next slow start. Right? Slowly we'll pick up pace. So multiple linear regression is very similar. The major difference here is we had X and Y there, right? Where X was our variable based on which we were doing the prediction. And then there was a dependent or an outcome variable. Here we have multiple um, um, variables which are there, right? And based on that, we want to make a prediction, right? So that is where the difference is. Now, the difference, one major difference is there we did not use any model. If you remember, we directly just used plot the regression line, that's it, and pass X, Y, B, and it did the work. Rest of the work we did manually. Like we calculated the B0 and B1, which is M and C and so on, right? For with its formulas and so on. Here, most of the work will be done by the the model itself, which we are picking up, which is ExcelR, right? So in that we have a data set called as Boston, and we have picked up the linear model. We have also picked up the matrix, and from there we are directly building a scatter plot and checking the values. That's it. Even the train test split, all those things here, everything is done via the model. So let's see one by one what it is doing for us, right? If you start with it, the first thing is the Boston data set. So let's see the data set. So before we run anything, let's go to the next line, next cell, and see the data set. If you look at datasets dot hash tab, you will see various options. So there is an inbuilt Boston dataset, there is a breast cancer dataset, diabetes dataset. Diabetes dataset also I am using a lot. So datasets which I am using to teach diabetes, Boston, then home loan from UK. Iris is used a lot with three flowers. Then there is in R, there is a car related one also. So these three or four data sets I'm using more in terms of teaching, right? So they are available here with us. So let's go back. What are we doing in this code, right? So first we are loading a data set. Yes. So let's see the data set also. Let's visualize it. Let's see it on the internet then. I'll just open it. Give me a minute. So yes. Okay. So here is our data set, right? What all things it has. So it has per capita crime rate by town. So it has all the acronyms, right? So proportion of residential land zoned for lots over 25,000 square feet. This is a Boston related data set from, I think, um uh, 70s or 80s, if I'm not wrong. It is a Boston housing data set. Then you have the Indus non-retail business acres per town, Charles Ravi dummy variable, nitric oxide concentration, which is pollution, average number of rooms per dwelling, proportion of owner occupied units built prior to 1940, weighted distance to 5 Boston employment centers, index of accessibility to radial highways, full value property tax per 10,000, pupil teacher ratio by town, and so on, right? All such things, median value of owner occupied homes. So many such things are there in this data set in terms of the values, right? Percentage of lower status of the population and so on. So all these values exist in our data set. And what we are trying to do is based on that, we are trying to build a multiple regression, right? Which is there, correct? Now here, how do we do the split? We do the split with 60-40. If you look at it, it will be given here. Here is your 60-40 split, right? Test size it is giving. Then directly you can get the coefficients and so on. And from there, you directly do the plot and you get many of the values. Just give me 5 minutes. I'll again share my screen after I run it. Right now, we need to remember few things here now that I have run it. Right, some things we need to be aware of. Right now, what is it giving to us as an output, right? For all our input variables, it is giving us coefficients. Now, it is not possible to directly plot this equation in our, just like y is equal to mx plus c plot that we did in the simple linear regression, right? So instead of that, our answer is actually all the coefficients for the various lines. And that is why in this three-dimensional or whatever number of dimensions that we are plotting those coefficients and kind of getting the values by getting the values for all of those. So what does that mean? So it means this. See, we are having y is equal to m1 x1 plus m2 x2 plus m3 x3 plus so on. We had about 10 or 15 variables here. So our answer to plot y is equal to, we are getting the coefficients m1, m2, m3, m4, m5, and so on, right? We are also getting, once we get this, any value that you want to get for y based on whatever values of the x1, x2, x3 variables, etc. is there, your answer comes. Is that something that I am able to convey to all of you? Let me recap. So see, we had linear regression that we did. That was simple enough because we had y is equal to mx plus c, right? Or error as we call it and so on, right? But I'm not writing that. So here it was simple enough. We calculated m, we calculated c, and from there we had an equation and we got y is equal to mx plus c. In our case of multiple linear regression, we have run the above plot, we have run the above code, but what is happening is we need to calculate m1, we need to calculate m2, we need to calculate m3, and that is what is our answer here. If you look at it, we are getting the coefficients for all the variables that we had, and based on that, our answer is coming. Now, with this coefficients with us, our equation becomes very simple. M1 x1 plus M2 x2 plus so on plus C plus error and so on, right? So that's our answer here. Now, the good part for that is, if with the model, the train split, the model fitting, all these things it does on its own with the equation. Now, again, with fitting and all these things, you need to remember, sometimes there is overfitment, sometimes there is an underfitment. Why does it matter? It matters because of this diagram that I will draw for you. Just give me 1 second. We cannot visualize directly with so many coefficients on our visualization that we have. That is why the answer here is in coefficients, right? In simplified terms. Now, what is overfitment and underfitment, right? I will draw two things here. This is a decision tree. I can go up till any levels. And let's say I have plots here, I have things here, and I build some sort of a prediction here or so on, right? And I have this. I go up till, let's say, 100 levels here. This is 100 levels. Now, the problem with this is overfitment. Same way, like when we had linear regression and we had dots here, we drew a line straight through it. I can also draw a line like this, right? All these are at times overfitment. Why? Can somebody guess? Why should I not go up till 100 levels of a decision tree? Or why a line which is actually going through all the points like this at times may not be as helpful as a straight line here? Or similar example, let me draw it again so that it's clear to everyone. I have points here, all these points. Okay. One option is to draw a straight line like this. Or the other option is to go like this for prediction. What could be the advantages and disadvantages of this? Same way our decision tree. Yes, no decisions like we were discussing in the past. I can go up till 100 levels. This length is, let's say, 100. What could be the problems that we have? Rather than drawing a straight line, we draw this, or we go up till 100 levels. So see, the thing is, a straight line gives you a constant predictability here. And if you go up till, let's say, 10 or 15 levels, you get a reasonably good answer without complexity. Reasonably good answer without complexity, right? If the scale here is very less, let's say the scale is just 2, 4, 6, 8, same thing here, 2, 4, 6, and 8. At that point of time, doing overfitting and going through a lot of things like this may or may not be beneficial to us, right? Rather than that, we directly go with a straight line, and that straight line gives us approximate answers as required. And the processing is also a lot easier, right? Same thing applies here also. I can take a decision whether to change a job or um, what my income should be based on where I'm working, what is my salary expectation, typically students' requirement, not in 100 steps, but maybe a 10, 15 step of a decision tree, right? That is easier compared to, let's say, a 100-step line, right? So that is what is overfitting and underfitting, right? We don't want to overfit too much. If I calculate 100 steps for a decision tree, it obviously takes me that much more amount of time and effort, computing power, resources, same things here. I can directly draw a straight line rather than worrying about the exact thing. Also, at times, not always, this is, let's say, the local minimum, this is the global maximum, this is global minimum, right? And so on, for whatever values in y and so on. So this might give you a wrong picture also, right? What happens when you are sitting here, the values that you will see will only be this much at that point of time with the slope, whatever at next point, right? So that also sometimes creates a lot of confusion in terms of overfitting. So it's a longer debate in decision science in terms of how you do the fitting, how you do the parameter tuning, and so on, right? But you need to remember, if you are here, your vision in terms of what are the values will be like, for y, I am not even reaching 2. But actually, for y, you are almost reaching up till 6 here, and maybe up till 8 here, right? So your vision is bounded by the global minimum. Whereas if you have done a prediction like this, a straight line, you know the slope continuously for it permanently is the same wherever you go, right? That is how you build the line, correct? So your slope is known, so your predictions are very smooth. Now, this very smooth prediction may or may not be helpful, depends on the use case, right? It will not show accurate data, yes, Rakhi, but it will give you a prediction which may be reasonably good for your problem, right? So that's what I'm saying. Fitting and parameter tuning is a more complex topic. There is no definitive answer. The answer depends on the use case. Sometimes it may be required that you go up till 25 steps in a decision tree. But sometimes within 10 steps, you may get a reasonable answer, right? You don't want too much complexity in your answer. So it depends on the use case in terms of what overfitting you have. Same thing applies to our multiple linear regression as well, right? M1, M2, X2. We are calculating all these coefficients, M1, M2, M3, and so on. At times, it may happen that if there are 20 variables and 10 are moving together, we cut out the 10 and only keep the other 10 with us, and maybe pick up only one from them, and it becomes 10 plus 1, which is 11, right? Which are not moving together. So There are many debates and discussions like this when you are working on a use case, right? These might unnecessarily influence the whole model, whereas all are moving in the same direction at the same time, right? So maybe all the financial parameters can be squeezed into one parameter, which is CIBIL score. Hardly anything will move in the opposite direction. Sometimes yes, but most of the times no, right? So that's a discussion on um, uh, overfitting, right? And obviously parameter tuning and multiple linear regression. What we did is, let me recap. Like this, right? We discussed about correlation, and if variables are moving in the same direction, what type of correlation they have. Again, correlation has its own calculations. If they are moving together, you remove one of them or multiple of them and combine into one, and so on, feature engineering and all such topics. And we discussed that visualizing y is equal to mx plus c is very easy, whereas visualizing uh, a multiple linear equation line is difficult for us. So what do? We calculate the coefficients. Once we have the coefficients, if you feed the x values, you get the outcome variable. So your equation is ready, right? That is what we did. We used sklearn. What were our steps in sklearn? Let's go back. Our steps one, test train split, test train split. We did 60-40. We did fitting. We ran the model after selecting, and we tried to do a residual error plot, which I just explained, right? Right? What are the errors that are there and so on. And from there, we got all the coefficients. Although this is not related directly to that, but we got all the coefficients, M1, M2, M3, and so on. And our Y was ready, right? So that's what you need to remember. Yes, Namita, correct. Eliminate the less important features which are not important. And so, Raki, sometimes the aim of, so Raki asks, it will not show accurate result for a test data. Sometimes we don't want 100% accuracy for the very same reason that I showed you, right? See, it is all about approximations here in data science. See, I can, I have, let's say, a plot like this. Okay. If I draw a line, regression line, it will go like this, something like this. Let me try to draw it straight away. Like this, something like this. There are two peaks here and something of this sort. You have two options. Either I can build a equation which will be difficult with lot of effort, which goes like this, or I can build an approximation here which is this, right? Which is this straight line, as you see, Raki, right? The cost in terms of computing power for this is very low. Cost in terms of computing power and effort for this is high, right? So sometimes we are doing approximations to have approximate predictions, right? And accuracy of 80-90% is good for us in a home loan. right? If we don't want to do such things, then plotting an exact line, like suppose we divide this into these areas, right? And building individual equations and then working with them might be a better idea. We probably don't want to do AI, ML, or data science, or we can use neural network, which can learn all this. But the cost to train a neural network is very, very high in terms of complexity, computing power required, processing power required, and so on, memory, and so on. So sometimes simple linear regression might give us answers which are sufficient enough for us. We don't need to worry so much about uh, the other things, right? So in this case, our answer is 70-80% right, approximately. That is okay with us. Rakhi, does that answer your question? That can also happen. Very correct, Rakhi. It can happen because all our values are here, right? In this zone. There are many perspectives to it. Our answer is in this zone. Now, if we model it, how do we decide what is the next step? If our values, new values come here, we have a problem. Absolutely. You got that right. So it's a very subjective and contextual discussion, right? It depends on the use case, how much money you are ready to spend, what type of model it is, what type of equation it is, what type of domain it is, and so on, right? That's why we are dealing in approximations. Okay. Okay. Let's go back. Let's try and see something else as well, if it is there. So they show us obviously linear and non-linear data also here, which is this. This seems to be going linear. This is non-linear. This is non-linear, which is clear to us. We just discussed that example here, right? So let me just quickly introduce the overfitting kind of thing in decision trees, right? So I don't know whether we briefly did discuss decision trees. So I am here, I am taking a decision. There are a lot many other technical things, just like I'm going to discuss the other things, we'll discuss this also, right? So you want to take a decision whether you will accept a job or not. What is the first thing that comes to your mind, students? If you want to accept a job, role, location, salary, what is important to you? Profile. Okay. So one of them says the role or profile. Package for others or salary, or let me call it CTC. So somebody says role, somebody says CTC. I'll start with role because as per me, that is more important. Yes, yes or no. Obviously, job satisfaction is related to role. That is why I said most will have role. Next would be obviously CTC. Next will be location and so on, right? Now, see, I can answer this sequence in probably 5 or 6 questions. Let's note those questions down. Role. Technical role is what many people will like, or techno functional, which will be like business analyst or something similar. Typically, freshers like it. CTC, anything above 5 lakhs is what typically people prefer. Location, so either close to home, or tier 1 or 2 city. Fourth, benefits like insurance and so on, right? Now, for a candidate who is fresh out of college, the 4 questions at 4 levels are good enough to select a job, let's say, right? Your role and job satisfaction, your CTC, your location, and the benefits. I can add a fifth one, which is culture. So let's make this as 5. Now, some people will overcomplicate this by asking 35 questions, right? Some people will ask 35 questions. Okay. Now, if you ask 35 questions, you will again get super confused. You are overfitting, right? You are overfitting. Simple 5 questions can be our answers for this thing, right? In our decision tree for taking a decision. Do you all agree? Do you understand overfitting? Rather than asking 35 questions, let's only ask 5 questions. 5 questions are important: role, CTC, location, benefits, and culture. That's about it. I would say, even for an experienced candidates, these 5 are very good questions, right? Now, before we end, let's also draw diagrams. Regression, line, and recap what we have done. Y is equal to mx plus c, y is equal to m1 x1 plus m2 plus so on. Clustering, every day I will draw this, right? So that you remember. Decision tree, SVM, neural networks, and so on, right? Ensemble methods. So you have multiple decision trees. You join the output of them together, or boosting, right? Ensemble, which is you join one or two together. Then there is also logistic regression, perceptron. So slowly we will study all this, right? So then we discussed overfitting, parameter tuning, fitting, and so on. Random forest, correct. So I think we will stop here. Please enter your attendance and you can ask questions. We actually covered a lot of things today, a lot many things which you can Google and read as well. Okay, good. So somebody said Chat GPT. We didn't see Chat GPT today. Let's see Chat GPT. Okay. Sorry, I kind of forgot that we also are going to discuss Chat GPT. So let's see whatever we have discussed today in Chat GPT. Okay. Yes. Let's also open Bard. Let's type explain overfitting in machine learning. See, I told you, right? Overly complex model. Um, you don't want to include too much of complexity there. Incorrect hyperparameters, lack of regularization. Let's see what this one says. It is a type of bias and is unable to generalize to new data. Cross validation is also a number of techniques that can be, so it is like stratified sampling, right? Cross validation. You build parts in the training data and then multiple times run over it. Ensemble learning, which means including multiple models on different subsets and then combining the predictions and so on. When model is too complex. What else did we discuss? Explain major algorithms. We haven't seen logistic regression. We'll see tomorrow. Explain major algorithms. Let me also tell you one new thing to explore. So, random forest, which combines multiple decision trees, logistic regression, support vector machine, naive Bayes, KNN, neural networks. Fine. You guys can explore this. Explain time and space complexity of algorithms. Try to read this. It will be very helpful. We will discuss tomorrow if I can. Let me note it down. So, code explanation, Namita, I have heard Bart does it better, right? Bart does the code explanation better. Let's add, let's do this. Uh, give me code in Python for multiple regression using ExcelR. It has given. See, this is our linear regression. It explains also. First line imports, second line loads the data, third line creates the independent variable, fourth line creates the dependent variable, fifth one is the linear regression object. This fits the model. Then there is predict, which is called, and then finally the score evaluates the model. Does this help you? Let's see the same thing in Chat GPT. Oh, sorry. See the split that we discussed, 60-40. Here they have done 80-20. Then they call fit method in linear regression. After training, you use predict. And from there, you calculate the error. And if required, you plot it. In our case, we had plotted it also. And you get the coefficients. That's about it. Can it draw diagrams? Let's see. Can you draw visualizations for major machine learning models? Let's see. I don't see the image. How do you see the image? Here, do you see? No. I'll find out how to give a prompt to get an image. Let's see in Chat GPT. It can provide code snippets and not the visualization. Thank you, Malali. So we will stop here. Anything else you want me to put into Chat GPT and BARD for today's topics? Explain hyperparameters. I think in the free model of BARD, it might not be there, but I will find out the prompting for it. See this. The number of layers in a neural network, the size of hidden layers, learning rate of gradient descent, and so on. Okay, so we will stop here. Yes, Malali, I think that question you can redirect to Amar in terms of internship. No, BERT is a search algorithm, Anuradha, as far as I remember. And uh, BART is the Palm model that they use just like ChatGPT. So there is a difference. I'll show you. There is a difference between the two. BART search algorithm. See, NLP. This is BERT. And BART, sorry, is the uh, Chat GPT equivalent. So there is a difference. Okay. Thank you, Ikrat. So you all have the attendance link. Now Amar will take over and he will be giving you the other things in terms of the attendance link and so on. Amar?
Yeah, thank you so much. So guys, I'm sharing attendance link with you once again. So please mark your attendance and please put your valuable feedback as well. If you have any query or question, please put in the chat box. I will take it up. Where you will get the material, Akshita. So we already upload the material in the LMS. So please visit the LMS. So day-wise material is there. Okay, please drop me a WhatsApp message. Guys, anything else? Any query? Yeah. If you don't have any query or question, you can leave the session. We are done with the.
Okay, thank you.
Okay, Sheetal, I'm sharing the attendance link with you. Just a minute. Sir, Google Bard has taken over ChatGPT. So please ask this question to Neil sir in tomorrow's session. 160521. Who is there? Okay, guys. So thank you so much for joining the session. We'll meet you again tomorrow at same time. Have a nice time. Bye bye.